Hello. As we have seen, statistical studies must be applied with caution. So let us consider an issue become of great interest since 2020: excess mortality. First of all, what is the validity of the data used to estimate mortality, since it is an estimate and not an exact reflection of reality? Mortality figures by cause are unrealistic. We cannot always identify the reason for the breakdown of a machine. So when it comes to an otherwise complex human being in the sphere of life where everything is subtly interconnected, where everything changes at every moment, and where a certain amount of free will reigns, we can even less identify the causes of death. It is usually the opinion of a doctor who has rarely, if ever, seen the patient. What is more, he has to form a quick opinion. In the US, the death certificate with the causes of the death must be completed within 15 hours of death. So common sense tells us that presumptions about causes of death should be taken with caution. Seemingly, statistical studies confirm this conclusion, suggesting that between 20 to 60% of presumed causes of death were incorrect even before 2020. But to seek quantified confirmation of this conclusion is to have little confidence in our reasoning capacities. There is a wide margin of error and it adds nothing to the debate. The presumptions about the causes are themselves based on assumptions. In addition, in 2020, many countries changed the disease codes on death certificates to favor COVID-19 as a cause, with the explicit instruction that it must be included even if it is only assumed to have caused or contributed to death. So, to estimate excess mortality, it is preferable to stick to all-cause mortality figures. Remember that a number is meaningless on its own. Only a comparison of numbers can be meaningful. More precisely, excess mortality is the difference between the observed number of deaths in a particular period and the number of deaths that would have been expected in that period based on historical data. There are so many parameters affecting expected mortality estimates that, just as with a survey, a choice has to be made from the outset, not forgetting that most of them are not really identifiable and even less quantifiable. So, as we shall see, depending on the parameters taken into account, excess mortality can vary completely from positive, namely with actual mortality being greater than expected mortality, to negative, that is less than expected. First of all, as John Ioannidis and his co-authors point out, death registration is very incomplete in most countries, such as India. So no study is valid in this case. For the others, the first parameter to choose is the historical period. The last 5 years, the last 10 years, more. Take an average, bearing in mind that the average is an abstract number, the arithmetic mean or the median, again a matter of choice. Or compare with a previous year. The further back you go, the less comparable the years become, since the conditions are more likely to be different. We could end up with the same problem as India today. For example, before the age of computers, the techniques used and the skills were not comparable with those of today, and so a comparison would be distorted. In France, a decree of 29th July 2006 replaced the paper death certificate with an electronic declaration. Any comparison of deaths from a period previous to 2007 should therefore be avoided. So let us try to answer the question: was there or was there not a positive excess of deaths in France in 2020? We take the figures given by Eurostat and go back to 2012 as Mayotte joined France in March 2011, and so it is not possible to compare with the previous period. The total number of deaths in 2020 is significantly higher than in any year since 2012. Let us add another parameter, the rate of increase. But what rate? If we compare each year with the previous one, the rate of increase, namely the number of deaths in a year A minus the number of deaths in the previous year A minus 1 divided by the number of deaths in the year A minus 1, all this multiplied by 100, we can see that it is indeed higher for 2020 than for the other years. Now you might say that simply comparing the number of deaths is unrealistic and that we need to add a parameter, the size of the population, since the larger the population, the greater the likelihood of deaths. But this size is an estimate based on census. Until 2004, they were far from annual. 1946, 54, 62, 68, 75, 82, 1999. They were supposed to include every individual on French territory, but in practice this was far from the case. Since 2004, but especially after 2008, they have become annual. But that does not mean we have precise numbers. It is done by annual installments. Municipalities with fewer than 10,000 inhabitants, or by sampling municipalities with more than 10,000 inhabitants. We have seen the problems of sampling. So the estimate of the size of the population is based on assumptions, approximations, in short, statistical models, and we cannot compare the years after 2008 with those before. For example, the population estimate on 1st January 2020 was slightly modified on the 14th of June 2024, namely more than 4 years later, which means that it is difficult to have an accurate estimate. Furthermore, since 2018, the census questionnaire has been modified to take better account of the problem of multiple residences, a change that adds to the inaccuracies of the estimates when comparing with years prior to 2018. Anyhow, let's compare mortality rates, namely total mortality divided by the size of the population. We still find that it is higher in 2020 than in any year since 2012. Unhappy with this result, we may want to add another parameter, age distribution. The greater the number of elderly people, the more deaths there may be, and so any comparison of deaths between 2 years ought to take this distribution into account. However, estimating age distribution is less reliable than simply estimating the size of the population. To estimate this distribution, we need to divide the population into age groups. More precisely, let us take the mortality rates of a past year for each age group and project these rates forward to 2020. Namely, find the expected mortality for each of these groups in 2020 if the rates had remained unchanged. Then add up the expected numbers for each group to find the expected number of deaths for the year 2020. We then need to decide which year to compare it with and how to choose the age brackets. Let us divide the populations of the years 2012 to 2020 into age groups of 10 years until age 79 and put the over 80s in a single group. We find that actual mortality in 2020 is higher than expected and that excess mortality is therefore positive, taking each year from 2012 onwards as the reference year. Let us now take age groups of 5 years up to age 79 and again a single group for the over 80s. We find that actual mortality in 2020 remains higher, and in fact that excess mortality is more positive than in the previous calculation if we take each reference year from 2012 onwards. Then we take mortality by age up to age 99 and put the over hundreds in the same group. We then find that actual mortality in 2020 will be positive for every reference year from 2014 onwards and negative, namely less if we take 2012 and 2013 as the reference years. In particular, as we see, taking finer age partitions does not prejudge the trend in excess mortality. Everything depends on mortality distribution in the age groups considered. We could have taken the average age-specific rates for the 2012-2019 period as a better reflection of this period and calculated the expected mortality in 2020 accordingly. We then find a positive excess mortality for 2020. We also have standardized age in other ways, taking the standard population distribution given by the WHO or that given by Europe. These are statistical methods. All these calculations assume an estimate of the population on January 1st of the year, but populations vary from month to month. So should we divide the year into 2 6-month periods, into months, weeks, or days? But the age distribution is not given for periods shorter than 1 year. So the finer the time unit, the more satisfactory it is in theory, but in practice, mortality estimates is less precise and will depend on the statistical model used. This is because it has to take account not only of deaths, but also of other factors such as migration, as well as the greater errors due to data collection for the unit chosen. By taking time units shorter than 1 year, some studies find a positive excess mortality for 2020. Studies have found significant variations in the conclusions on excess mortality, depending on the various choices made. Population distribution, number of years included in the reference period, and the time unit of the mortality series. The statistical model used, in other words. Other parameters could be added. For example, as Ioannidis and his co-authors point out, adjusting for changes in other high-risk indicators, such as stay in long-term care facilities, can also make a difference. There is also the harvest effect, namely sick or elderly people who have managed to survive for a few years may suddenly die. What is more, the weather is never the same from one year to the next, and a new chemical may be introduced or an old one withdrawn from the market. Then there are electromagnetic factors. Scientific and therefore empirical studies show why radiations from mobile phone masts are harmful to health. So the increasing use of Wi-Fi and the introduction of different generations, 2G, 3G, etc., may have an impact on mortality. To this, we can add social and psychological factors. For example, fluctuating living conditions in different social groups. How can we quantify these living conditions or changes in the degree of stress and anxiety due in particular to the economic situation? Society may also be divided into groups in more than one plausible way, and these groups may vary over time. In short, for 2020, we cannot determine whether or not there is excess mortality. The problem is that a study of excess mortality is meaningless, because what are we comparing? The death of one person in a given year with the death of another person in a different year are events that most often have nothing to do with one another, just as two tosses of a coin are independent events. What is more, it may come up tails several times in a row or alternate between heads and tails, and we cannot draw any conclusions about the quality of the coin. Similarly, we cannot draw any conclusions from the excess mortality numbers. Basically, a statistical study of mortality comparisons, namely descriptions of reasons for death obtained statistically, does not allow us to conclude anything in particular, whether or not we should be looking for new causes. As for these causes, any model can be interpreted in incompatible manners. If the model indicates a positive excess mortality rate, we may think that this is due to a contagious pandemic, or on the contrary, to the measures taken. If it indicates very low or no excess mortality, it may be thought that this is due to the measures taken or that there was no pandemic. Only in the case of extraordinarily high or low mortality in a given year can we hope that all the methods used will give more or less the same indication. But in this case, a statistical study of excess mortality would be futile because our senses, our perception will indicate the occurrence of exceptional events, not necessarily a pandemic. So was there or not a pandemic in 2020? As explained in the previous video, only a scientific study can answer this question. To date, no study is known to have been able to establish the phenomenon of contagion by particles or organisms too tiny to be observed with an optical microscope. This does not mean that there was no pandemic, because there are indeed unknown and unidentified phenomena. Perhaps tomorrow the contagion thesis will be established on solid foundations. Moreover, even if contagion does exist, it could be that a pandemic never reaches a large scale except locally, which explains the regional variations in mortality that appear in some models. Indeed, one hypothesis has been suggested by scientist Thea Newman, according to whom with respiratory diseases, there are debris in the air of these particles or organisms that are not infectious, but may help to stimulate resistance through being breathed in small doses. This hypothesis would help to explain why, when there have been severe outbreaks, there seems to be an enhanced immunity in broad geographical areas around them where dust particles can be carried by the wind. In more remote parts of the world, beyond the range of these debris, the epidemic will start again with full vigor when introduced by air travelers. Newman applies the hypothesis to the very different patterns of spread of the disease in different parts of the world, like Asia, Europe, and the Americas, and also to the striking differences between countries. According to biologist and leading critic of current science, Rupert Sheldrake, combining Newman's hypothesis of a preconditioning field with the idea of morphic resonance, which could selectively enhance the response of people to debris, might illuminate some of the otherwise puzzling phenomena in this pandemic. For the moment, all of these remain hypotheses, which require the very existence of these particles or microorganisms to be established on a solid scientific basis. Statistics certainly cannot provide the answer. Thank you.